Good afternoon everyone, my name is Luke and along with the help of my team members Aniket, Daniel, Joanna and Niels, we're here to show you exactly what we've been working on for the last 3 weeks. Cabbed. Cabbed is a proof of concept Flutter application built for both iOS and Android, designed to level the playing field within the rapidly evolving taxi industry. The sharp rise in app-based ride-hailing businesses has forced the traditional black cab industry into a period of forced innovation if they are to survive. Because of this, we chose to design a real-time customer hotspot locator, taking advantage of the Google Maps heat layer to provide the user with continuous data on the intensity of customers at geographical points, all based on data returned from other users. This allows the user to consistently assess footfall around the city, allowing drivers to both target and avoid busy and quiet locations, fine-tuning their shifts in order to maximize cost efficiency and thereby enhance profit margins, all the while providing greater accessibility to the general public. I'm now going to pass you over to Niels, who's going to present you with a demonstration of exactly how Cab works.
Thank you, Luke. Without further ado, we'll jump into the presentation of our app. As you can see, we've come to the login screen of our app. Here we can choose to either log in with our social credentials or we can do it through the user sign-up form. For this demonstration, we choose the user sign-up form. We'll fill in the details of our new user and then at last we'll add a picture from our downloads folder. Normally we would use the camera function of our mobile phone, but for the purpose of this demonstration we're using an emulator, so that's not possible. We then click the Let's Work button, which makes a post request to our database and returns a message that the user has been successfully created. From there it will take us automatically back to the login page. Once we've finished the sign-up process, we return to the main screen to log in with our newly created user credentials. We tick the Remember Me button to signal to the app to remember us the next time we start it. After we log in, we come to the main screen of the app, generated with the GoogleMaps API. We see a lot of custom markers on the map. These are placed by our other users and we'll return to them shortly. For now, we are going to click the bottom left button on the screen and toggle our current footfall heat map. We make a decision based on the current hotspots within the city and decide to travel to the Manchester library first. While we set off on our journey, we decide to have a look at the map. While traveling, we can see we are going to cross a few markers on our way. These markers indicate social events or other things the other users of the app want to make someone aware to. They are placed by pressing the top button on the screen, something we will do shortly after. By clicking on any of these markers, you will get a time of placement. These stay active for up to an hour and then they disappear. As you can see from the demonstration, we decided to place a police incident marker on the road that we are traveling on. These will pop up directly and in real time for any other users. As we arrive to the Manchester Central Library, we pick up our first customer and click the pickup button. By clicking the pickup button, we send a post request to our database with the information of this pickup. We use this data to generate future hotspots based on the data submitted. As we will do now, we will toggle the current heat map off and we will click on the past heat map. The past indicates past hotspots based on the last 4 weeks of submitted data by our users, and it clearly signals that Manchester Piccadilly will be rather busy for the coming hour. It might be wise for us to travel there. For now, we decide to click on our user profile. From there we can see an overview of all the markers we've placed, the pickups we've placed and our user score based on those totals. It also gives the user the ability to log out, which is what we'll do next. Logging out returns us to our home screen, and that concludes the presentation of our app. For now, I'll hand you over to my teammate Daniel, who will talk you through the front end.
We chose to build our front end using Dart and Flutter. We knew we wanted to build a native cross-platform app and saw React Native and Flutter as our two main choices. After some spiking in the first few days, we chose Flutter for a number of reasons. Flutter has a huge library of UI components which we could use to easily customize our app. We really like Flutter's DevTools suite for debugging, and this, along with the hot reload feature, would allow for speedy iterative development. We also found that Flutter and Dart had great clear documentation, as well as a wealth of online learning tools. We spent a lot of our time in the first week familiarizing ourselves with Dart, as this was a completely new language for all of us. Using local emulators, we were able to run a live version of our app on our machines for development and testing. For the map portion of Cabd, we used the GoogleMaps Flutter plugin. The heat maps functionality for this plugin is brand new, so documentation was sparse and use cases were few. However, this was the only plugin we found with all the functionality we wanted. Although it was challenging, we were really happy with how we got things working as we had originally envisioned. Upon loading the map page, the map centers on your current location and HTTP GET requests are made to our backend to get relevant points from markers and pickups, which can then be displayed on the map. This data is refreshed automatically every 2 minutes with a fresh GET request. New pickups and markers are added with post requests when the relevant buttons are tapped. We also used Adobe XD to create views of our app, and Adobe Illustrator and Photoshop to create design elements. Throughout the project, we employed agile working practices. As we were using tech that was new to us, it was difficult in the beginning to predict all of the challenges we would face. Agile practice allowed us to react quickly to relieve bottlenecks. Using pair programming and mob programming to combine our skills and knowledge where challenges arose. Throughout the project, we kept up to date with twice daily stand-ups, where we reviewed and updated our Kanban board on Trello. This allowed us to remain focused on our MVP and let the design evolve iteratively. I'm now going to pass you on to Joanna to talk about our backend stack.
For the backend, we used an Express server and Mongoose to connect to a MongoDB database. After spiking some ideas for the database, we chose MongoDB because thinking long-term scalability was really important, as the database would need to store large amounts of data. MongoDB uses horizontal scaling to solve this problem, so we could increase the amount of data with zero downtime and using multiple servers. Another reason we chose MongoDB was creating the database was a lot easier than some other databases, as it is flexible and it avoids the concepts of joins. Naturally, after choosing MongoDB, we decided Mongoose was best fit for connecting to an Express server. The database has three schemas: users, which has all data for a user profile, pickups, and markers. The pickup schema has all previous pickups and made by all users, and likewise for the markers. When a user signs up, the data is posted into the user schema, and when they log in, it sends back the user's data. We wanted to make sure all passwords would be encrypted for user security, and to do this we used Argon 2, a cryptographic hashing algorithm. For the pickups and markers, the user can see all the data posted from the past hour. When a user makes a post request, the data has the coordinates of the location, and we also included the user's ID, so when you go on their profile page, you can see how many markers and pickups they've made. The markers also have a type of event, which the user picks from the drop-down list. We also thought it was important not only to show data from the past hour, but data from the past hour for the past 4 weeks. And to do this, we had to separate the time and date. We used a package called Moments to format the timestamp in the schema and have time and date separate, so that we could easily filter through the data and send back what was needed. We tested the endpoints using Mocha, Chai, and Supertest. And in order to test all the endpoints successfully, we had to have a large amount of data from the past 4 weeks with different locations, different times, and different types and different users. To do this, we used random generator functions. For the coordinates, the function would take the radius and a center point, and for this example, we used St. Peter's Square. The function would then create random coordinates within that area. We did the same for all information needed for the database, and we then tested the data to ensure that what we were sending back was in the correct format and added it to the database to be used in the front end. I'll now pass on to Aniket, who will talk about the challenges we faced and what we would have liked to have done differently.
Thank you, Joanna. One of the major challenges we had was to emulate footfall data. We were looking at APIs that could provide real-time data, essentially providing data that tracks people, which was impossible. So for testing and demonstration, we had to emulate the data by creating a JavaScript function that gave us a number of coordinates within a mile radius of Manchester. Another problem we had was working remotely, and so far we are the only international team working in different time zones. This was of course challenging, but we managed to find a solution using various tools at our disposal, such as Zoom for cloud meetings and daily stand-ups twice a day, VS Code Live Share for pair programming, Git for version control, and making use of standard agile practices, making it quite easy. Overall, we had a great experience working together as a team, and although we were not very familiar with some of the tech that we used, we learned how to use them, and we are very proud to show all of you what we created. I'll pass you over to Luke now.
So, as I look forward to the future, there are a few things that we'd like to see happen. Firstly, as I said at the start, our application is reliant on the participation of multiple users. With no users, we have no data, and with no data, we have no product. Because of this, we'd like to see a real-time acceptance test across the city in order to truly determine whether or not this meets a business requirement. Second is scalability. As Joanna alluded to, we chose mongoDB for its scalability benefits. Our app is currently only designed around Manchester city centre. However, we would like to see it grow across other major cities across the country. So, on behalf of everyone at Cabd, we would like to give a massive thank you to everyone who took the time out to watch our presentation. We hope you enjoyed it as much as we did, and we hope you enjoy the rest of your weekend. Thank you.